Hi everyone, in this video we will discuss three questions from the SAT Math Practice Exam 1, Section 3 without calculators. Okay, so these questions are, if you look at these questions that we are going to discuss, these are related to polynomials and quadratic equations. The topics that are related to polynomials, quadratic functions, and all that type of functions. Okay. Right. Okay, let's see. So the first question says, okay, for the function g defined above, a is a constant and g of 4 equals to 8. What is the value of g of negative 4? Okay, right. So just to give you an idea, so when you have for example, if you have something like f of x equal to x plus 4, right? Let's say, for example, you have this equation. Right. So when you have like say something like if you have f of 2, which means that simply you just substitute for 2 for 2 for x. So what you do is you have, instead of x, you have 2 plus 4, which is equal to 6. So this is just a small revision for students about functions. Like, okay, let's say if you have f of negative 1. So this means you have negative 1 plus 4, which is the same thing as 3, right? Negative 1 plus 4 is 3. Okay, let's say if you have f of um, y, right? So you can even put any variable inside this. So f of y, you just plug in y instead of x. So y plus 4. So what this is meaning that is that if f of x is x plus 4, right, meaning if you have x over here, you have x over here. If you have 2 over here, you have 2 over here. If you have negative 1 over here, you have negative 1 over here. If you have y over here, you have y over here, right? So that's the whole idea of this notation, f of x equal to x plus 4. That is notations of these functions. Okay, right. So coming back to the question, they're asking to find the value of g of negative 4. Okay, well, the issue is like there's this a number, a letter a, which we know nothing about, right? Okay, so how are we supposed to find g of negative 4 if we don't know anything about it? Okay, let's go about calculating g of negative 4. G of negative 4 is equal to a, and you substitute 4 instead of negative 4 squared plus 24, right? Okay, so this becomes 16, right? So when you take the second power of a negative number, you just ignore the negative sign, you just consider it to be a positive, the answer. So you get 16 times a plus 24. This is what you get. Okay, so what the hell is 16a plus 24? Because we don't know anything about a. But look at what they have given us already. G of 4 equals to 18, right? Equals to 8, sorry. So let's go there. Let's see what g of 4 is. Okay, a times 4 squared plus 24. Okay, 4 to the 2 is also 16, right? Nothing else. So 16a plus 24. So what does this mean? So g of negative 4 is the same thing as 16a plus 24. Is the same thing as g to the 4, right? So these two are equal. Meaning that g of 4, well, let's say g of negative 4 is the same thing as g of 4, right? These two are the same thing, 16a plus 24, 16a plus 24. So what is g of 4? They have already said this. This is 8, right? So your answer should be 8. Right, so going back to the question how we managed to solve it, you realize that, so you have this x squared here, which is actually insensitive to the sign of x. This is insensitive to the sign of x. If you have, I mean, if whatever, I mean, if you have x equals negative 1, maybe like, for example, let me say like this. So let me write this particular function, you have g of negative of anything is equal to g of the same thing with positive. G of negative 100 would be equal to g of 100. So that's the key takeaway. So looking at these functions, you need to train. I mean, it's useful to train your eye about this. So whenever they say, okay, give you g of something, and then you need to find g of the other thing, right? So think about how the function changes with these two values, right? So in this case, there's no change at all. Okay, right? Right. So let me show you something else. A similar function, similar question, for example. Let's see if this one. So you have h of x is equal to um, x cubed. So x cubed, h of x is equal to yes, a times x cubed. Let's say you have a times x cubed, and they say, okay, this is h of 1 is equal to, well, not h of 1, let's pick, yeah, let's say h of 1 is equal to 3, right? Okay, so you say that h of 1 is equal to 3, but now they want you to find h of negative 2. Okay, let's see how we can do this. So h of negative 2 is equal to, so what is h of 1? So h of 1, you just plug in 1 into this, you get a equals 3, right? Because you just plug in 1, you get 1, a. And they want you to find this. Okay, so a negative 2 to the 3. Okay, so you know that a is 3, not is negative 2 to the 3, that's just going to be negative 8. So what does this mean? This is just going to be negative 20. Right? So these are similar questions that they could give you. Okay, so let's do another one example. Um, there's a, let's say you have um, f of x equals, we can have 2 to the b times, yeah, a times x, right? So this is your equation. Okay, so they would say, okay, f of 1 is equal to, let's say f of 100, right? So f of 100 is equal to 3. They're saying this. Okay, find f of negative 100. Okay, so what do we do here? So what is f of 100? So if you just plug in f of 100, you get 200a, 2 to the 100a. So this is like 2 and then power 10a equals 3. Okay, so what is this? 2 negative 100a. So what does this negative sign means? Negative 100a, right? So this is simply equal to, when you have a negative exponent, you can just take the reciprocal of that. 1 over 2 to the 100a. Alright, what is 2 to the 100a? That's just 3, right? So this is just going to be 1. So you see that f of negative 100 is 1 over 3, right? You don't need to find anything a, you don't need to do anything fancy with logs and all that. It's just purely being able to visualize how the x values influence these numbers, right? Okay, okay, okay. So I mean, I will add more to this. Let's see, let's say if you want to actually find um, yeah, so let me add another page. So let's say if you want to find, it's the same question that I'm dealing with here, right? I'll just keep it over here. Let's say they want you to find f of negative 200, right? Okay, so what do you do here? So let's try this. This is just f of negative 200a. Okay, I think we have discussed this earlier about exponent. So you see that what is the difference between negative 2 to the 10 100a time and this? So I can do this, right? 200 to the 2 to the 100a times negative 2. So this comes from the um, properties of exponents. Okay, so what do we know about 2 to the 100a? That's just 3. 3 to the negative 2. Okay, so how do you deal with this? You have negative exponent, you take 1 over 3 to the 2, which gives you 1 over 9. So your answer would be 1. So you see how things can be. So when you have something like this in SAT math, there's obviously going to be some easy manipulation like this. You don't need to actually deal with a lot of stuff, right? So please be, I mean, you try to be like, really attentive about these types of tricks. Okay, right, okay, so let's move on. Okay, so this is another question that I would want to discuss today. So we have, okay, so this is a little bit, maybe sometimes students may get thrown off by a lot of, you have a, b, and then you have c, and you have an x. Okay, right, so let's go back, let's go and see what they want. They want what are the two possible values of c for c. Okay, so they want you to find c here. C is over here, just spot that on the equation. Where is c? C is over here. C is over here. All right, so what do we do? So this is a factor, and this is in just the standard form of a polynomial, of a quadratic function, right? Okay, so let's just distribute this and see what happens. Let's distribute that. So let's see, ax plus b and bx plus 7, right? Okay, so let's distribute that. So you distribute these two, you get a times b x squared. Fine. You multiply this and this, you get 7a times x. You have ax times 7, that is 7a plus. Then you distribute this over here. Oh, wait a minute. This should have been 2 here. Sorry, my bad. This is 2 here. You multiply this, expand this over here, you get 2bx, and then you expand this over here, 2 times 7, which is 40. Okay, so let's write this out. So abx squared, take the like terms together, you have 7a plus 2b plus 40. So what do we know about this? We know that this thing is equal to this 15x squared plus cx equal to 14. Okay, let's set this thing equal 15x squared plus cx plus 14, right? Okay, so there's one more key thing. It's not just an equality. This is true for all values of x. So meaning that they are true for all values of x is that they're saying they are identical. The two sides are really identical. It's not just an equation we can where you solve for x. It's basically an identity. So this means that the two sides of the equation are identical. So what do I mean by identical? Okay, look at this equation. So right, so you have this x squared term here, right? So this means that a b should be equal to 15. So because, like, let me just circle this around. So this is a b and this is 15, right? Which is the thing of this. And let me write this in red. So these two should be equal, right? 7a plus 2b equal to C. And not surprisingly, this 14 is equal to 14. That we know. Yeah, it's really obvious. Okay, now what do we have? So we know that one thing we know that is AB is equal to 15, right? And we know that C is equal to 7A plus 2B. Okay, so we are supposed to find 7, right? And that is equal to 7A plus 2B. Okay, what do we do now? Let's go back to the question, see what we can do. And A plus B equal to 8. So they have given an extra information, that is A plus B equal to 8. Fine. Alright, so this is SAT math. So we can actually browse through the solutions and to see which one matches, right? I mean, even without looking at this A plus B equal to 8, if you look at, oh, wait a minute. So, sorry, they're asking for the C value, sorry. So you have AB equals to 15, A plus B equals to 8. Okay, can you guess any numbers that matches this? So I would guess A equal to 3 and B equals to 5. One thing else you can guess is A equals 5 and B equals 3, right? So it seems that these are the only two answers that should be there, because they say there what are the two possible values for C. So you know you have two different answers. So if you have A equal to 3, B equals to 5, you have C equals 7 times A, 7 times 3 plus B, which is 2 times 5. So 21 plus, so this is 21 plus 10, which is 31, right? Over here, C equals 7 times 5 plus 2 times 3. So 7 times 5 is 35 plus 2 times 3 is 6, 41, right? Okay, so do we have this answer, 31 and 41? Yes, we do have. That's D, right? D here. Okay, I know that this is a rather long, and it's a very technical answer. So the key takeaways is that be careful with these terms. For all values of x, meaning this. For all values of x. That's a really strong statement, because it's not just a typical equality. This means that the two sides are basically identical. So meaning that if you actually distribute this thing here, you should end up with the same equation on the right hand side. Okay, so what do? We just expand this out, distribute this, and you end up with this equation. You have several coefficients for x, right? X coefficient is C, and over here it's 7A plus 2B. A, B, 15. So basically you set them equal to each other, and with this additional constraint, given, well, let me just, this is given in the question, and you solve for A and B, right? Okay, and then you end up with the answers. A equal to 3, B equals to 5. Just use all these two values in this equation, C equal to 7A plus 2B, and then you end up with two answers, 31 and 41, and that is it. Okay, right. I hope this was helpful to you. Let's move on to the next question that I am planning to discuss. Okay, so this is from the written part of the section 3. Okay, so they want you to find if t is greater than 0, meaning that t is positive, right? That is what you mean by t greater than 0. And you have this equation t squared minus 4 equal to 0. What is the value of t, right? Okay, so first of all, think about this equation. So whenever you are asked to find some t value, and then you are given equations and inequalities, what you need to show. So this is an inequality, right? And this is an equation. Okay, right. So whenever you're given an both an inequality and equation, I would suggest go for the equation first, because that gives you a definitive answer or answers, whereas the inequality is just you It's a lot of, I mean, what can you say about, like, when you say t greater than 0, it's t is positive. I mean, there's a whole lot of positive numbers. So an equation which you will give you the most information, and then maybe you can use the inequality to actually analyze the answers more, right? More deep, analyze them more. I mean, into analyze the answers more into the question, right? Okay, sorry. Right, so we have t squared minus 4 equal to 0. There's two ways that you can deal with this. One way is that you can actually move 4 to the other side, just by adding 4 on both sides. You end up with t squared equal to 4, and you take the square root. Then you end up having t equals to plus or minus 4, right? Don't forget the negative sign. There's two answers, so what is the square root of 4? That's just going to be 2. So we have plus or minus 2. So the answers are, so there's going to be two answers for this equation, negative 2 and positive 2. But they say t is greater than 0, right? You can't use this, so this you can just ignore this. This is the answer. So t is equal to 2. Okay, fine. This is one way to solve it, and then there's another way to solve this. So we have t squared minus 4. Okay, let me write this important algebra fact. This will be later useful in other questions in SAT as well, algebra fact. So when you have a squared minus b squared, you can always factor this out as a minus b plus times a plus b. Okay, so let me write an example on this. 3 squared minus 2 squared. So you end up having 3 minus 2, 3 plus 2. Okay, so I mean, you can, if you don't like squaring numbers, you can try this method. 3 minus 2 is 1, 3 plus 2 is 5. The answer should be 5. Okay, let me write another. Okay, so this is fine. Okay, let me, I hope you get the idea. So we have t squared minus 4 equal to 0. We know that 4 is 2 squared, right? So t squared minus 2 squared is equal to 0. Now we just factor this out using the fact that I mentioned out. So t is like a, b is like 2 is like b, right? T minus 2, t plus 2 equal to 0. So when you have a factorization like this, what do you do? Typically, you set t equal to 2 or t equal to negative 2, right? Okay. Or maybe I'll just write an extra step here, which means that t minus 2 is equal to 0 or t plus 2 equal to 0. Okay. So if you move around the 2 in this equation, you get t equals to 2 or t equals to negative 2. Again, since t is greater than 0, this is wrong. This won't be the answer. T equals 2 will be the answer. Okay, so out of these two answers, students may be more familiar with this answer, more familiar, let's say. Maybe, I don't know, it depends on how they have learned this in class from their teacher, but this is more familiar for students and this is less familiar. But this is technically, this is the more technically correct way of doing this question, right? More precise way, right? You will see this when you actually maybe if you planning to move on to the to more advanced mathematics, you will see why this is technical. But I won't discuss this at this point, but leave it at this point. If you want to learn more about this, just let me know. Right? Contacts and leads are in the description. Okay, right. Anyway, so just remember this algebra fact. I'll just rewrite this over here. A squared minus b squared equals a minus b times a plus b. Okay, so you can even, for example, let's say you have example, let's say for example x squared minus 100. So this is just x squared minus 10 squared. So you get x minus 10 x plus 10. Okay, that's how we do this. Okay, let's see this example. We have x to the 4 minus y to the 4. Okay, but this is not 2, this is 4, right? Okay, let's deal with this. So we have x to the 2, using properties of exponents, you have x to the 2 to the 2 minus y to the 2 to the 2. Okay, so we can treat x to the 2 and y to the 2 as this a and b. So you get x squared minus y squared and x squared plus y squared. Okay, nice. Now again you have x squared minus y squared itself, right? Okay, we can write this as x minus y, x plus y, and x squared plus y squared, right? Right, so this is a nice way of using that formula. Anyway, so I would say these types of tricks would be really helpful in SAT math. So yeah, feel free to contact me about learning more tricks like this, right? So there's so much that I can do in one video, but if you're interested, just let me know. All right, okay, so see you in another video. I hope you learned something really important from this video that I did today. Okay, so see you then. Have a good day.